Okay, so the last operation that we're going to see on vectors is actually the easiest one. It's called a scalar multiple. So what's a scalar? Well, actually, it's the same thing as in this course, at least, as it's the same thing as a real number. Okay. So not to make things too complicated, just think of it when every time you hear the word scalar, think it's a real number, okay? But it's not a vector. So what's important to remember is the scalar and a vector are two different things. Okay, a scalar has no orientation. It's just something that has a magnitude and probably also a positive or a negative sign. Okay. Eventually, it's going to scale our vectors. So what I mean by that, so imagine you've got vector v here. I'd like to have a vector that's pointing in the same direction but twice as long. Okay, like this one. Okay, we're going to call that vector 2v. Okay, 2 times the vector v. You can see why why that is. It's basically v to which we add v again, right? If we want to get a vector that's twice as long. So that's why it's 2v. So it's v plus v. But ultimately I could have a vector that's, I don't know, 2/3 of v. Okay, that's also possible. Okay, and so on. I could have also a vector that's going the opposite way. Okay, so maybe opposite but twice as long. Okay, so that's going to be the vector minus 2v. Okay, for a very good reason. It's because minus 2v, well, it comes from the fact that it's going to be 2 times the vector minus v. Okay, so those are the same. Okay. All right, so how do we do this algebraically? It's very simple too. If we've got v which has coordinates 1, 2, if I'm gonna create a vector that's twice as long, all I need to do is double the coordinates. Okay, and that's not hard to see geometrically why that is, right? If I've got a vector that's, I don't know, 1, 2, so this is v here. Okay, if I want to make it twice as long, well, okay, it's going to be this vector here, and it's not too hard to see that its coordinates are going to be 2, 4. It's going to be twice as long along the x-axis, twice as long along the y-axis. All right, so super simple. So that there's not that much to say here. Oh, maybe one little thing to add. Maybe often for scalars, if I want to use a variable to so that I don't assign a particular value to that scalar, we're going to use the letter k. So often you'll see in the book kv. So that's typically a letter used for a scalar, and that's typically a letter used for a vector. Okay, so you could also see things like kv plus lu. So typically we're going to use letters that are in the middle of the alphabet and starting with the letter k usually for scalars. And we're going to avoid using, and we're going to see why later on, but ij, we're going to try to avoid using them. Okay, they're going to be used for something else. So for scalars, k, l, you could use m, you could use n. Those are all good choices for scalars. All right, so I could write, kv. That would be the same as in terms of coordinates. If this is v is the vector with coordinates v1, v2, that would be k v1 plus k v2. That's exactly what I've applied here. You see, this is 2 times 2 up there. This is 2 times, that was 2 times 1, and this is 2 times 2. 2 times 1, 2 times 2. That's how I obtained the 2 and the 4. I did k times v1 and k times v2. All right. Okay. What else? There's also something maybe you should be aware of. There's associativity of vector addition. Associativity of vector addition. what does that mean? What's associativity? Well, here's what associativity means with numbers. If I do 2 plus 3 plus 4, okay, to do this addition, I could start by doing 2 plus 3 first and then add 4, but I could also do 3 plus 4 first and then add 2. Okay, I can do this, right? So no matter where I put the brackets, it's the same. It's going to give me the same result. So that's why often we don't put any brackets. We just write 2 plus 3 plus 4. The reader can just perform the addition in any order that he wants to. You could add the 3 and the 4 first together, or the 2 and the 3. It doesn't matter. On top of this, we've got commutativity of vector addition, which means that 2 plus 3 is the same as 3 plus 2. So if I want to, I can also change the order of the addition, right? I could do 3 plus 2 plus 4, and that's the same thing. I could do 3 plus 4 plus 2, right? That's also because I've commuted the 2 and the 4 here. So in fact, all rearrangement of 2, 3, and 4 added up together will give me the same result. Well, that's also true for vectors. Okay, how can we see this? I'd like to show you that u plus v plus w, no matter how I add them, it's going to give me the same result. So how does that work? I could use an algebraic proof. I like here to show you a geometric proof because it's kind of nice. So if let's say I have u, v, and let's say w is here, okay? If I do u plus v, well, it's this vector here, right? U plus v. So what I'm trying to do right now is do u plus v plus w, u plus v first and then add w, and then after that I'm going to do v plus w first and then add u, and see that it will give me in the long run the same thing. So u plus v is right here. If I add w to it, I'm going to get this, right? So let's follow I'm following the path created by u plus v and then by w, and I end up with this, u plus v plus w. Okay, maybe let's change color for next part. If I do u to which I add v plus w, okay, let's do v plus w. V plus w is this. That's v plus w. I'm just following the path created by v and w, v plus w. And now I do u plus v plus w. So u plus v plus w, I end up with this vector again, same vector. So this is u plus v plus w. So they are equal. Okay, so all these are equal. So in fact, it doesn't matter where I put the brackets, and often I won't put any brackets because it doesn't affect the final result. Well, so u plus v plus w, I can just keep it the way it is. It's up to the reader to decide how he's gonna add up the vectors initially. And just like for numbers, addition of vector commute, so I could also rearrange the order of the addition, and it won't change anything. So I could do u plus w plus v, that's the exact same thing. I could do w plus u plus v, exact same thing. So any rearrangements of u, v, and w added up together will give me the same result.